On May 8, 2026, the CDC's Health Alert Network released a notice regarding a cluster of severe acute respiratory illness in the South Atlantic. The metrics from the vessel involved were high: 8 total cases, 6 confirmed, 2 suspected, and 3 deaths. Clinical tests identified the Andes virus. It is the only hantavirus documented to spread via person-to-person contact, and in patients with respiratory symptoms, the case fatality rate is approximately 38%. The trace begins in Ushuaia, Argentina, where the cruise ship departed on April 1, 2026. The ship's trajectory took it across the South Atlantic, intersecting with the specific coordinates of 37 degrees 18 minutes south, 12 degrees 40 minutes west. The arrival of a transmissible pathogen at these specific coordinates represents a convergence of biological and geographical factors, with zero margin for error. The Tristan da Cunha archipelago is defined by its distance, 3,700 kilometers from Antarctica and 2,800 kilometers from Africa. This system formed over the Gough mantle plume, where basaltic magmas delivered from deep in the mantle created subaerial rocks dating back 18 million years. For the human settlement at Edinburgh of the Seven Seas, this geology is a boundary. The village is pinned between the ocean and a wall of green volcanic cliffs that allow no interior transit. On Inaccessible Island, the perimeter is even more restrictive, consisting of continuous 300-meter vertical basalt cliffs and high-energy wave-cut platforms. The bathymetric drop-off matches the terrestrial verticality, with submarine flanks inclined between 25 and 45 degrees, descending into abyssal plains exceeding 3,500 meters. These basalt structures have shielded the interior biosphere for over 1 million years. However, in a contamination scenario, they function as a boundary that prevents any viable exit or external intervention. To model the impact of a respiratory virus on a closed population, we looked at data published in PLOS 1 by Matthews and colleagues, comparing clinical attack rates. The 1918 H1N1 pandemic provides a baseline for a continental population with partial pre-existing immunity. Because of heterosubtypic immunity from prior seasonal exposures, only 25% of Royal Air Force personnel in military camps reported illness during the pandemic wave. That baseline contrasts sharply with the records from the 1971 H3N2 outbreak on the isolated island of Tristan da Cunha. On the island, the clinical attack rate was 96%. This chart shows the basic reproduction number, the R0, derived for that outbreak. The MCMC distribution reveals a median R0 of 6.4, with a 95% credibility interval reaching as high as 10.7. At this transmission level, incidence doubles every 1 to 2 days. Centuries of geographic isolation create a host profile lacking the immunizing exposures common in global populations. In this vacuum, a single introduction cascades into population-wide infection. Immunological vulnerability is a direct result of deep-time biological isolation. The Inaccessible Island Rail, Atlantisia Rogersi, is a case study in how closed systems prioritize optimization over defensive flexibility. Genomic sequencing shows the rail colonized the island roughly 1.5 million years ago, descending from South American flying crake ancestors. The skeletal transition was absolute. Notice the reduction in the size of the sternum and carina, alongside a compensatory widening of the pelvi and thickening of the femori. These metrics confirm the loss of flight. The average weight is between 34 and 49 grams, and with a wing length of just 54 to 62 millimeters, powered flight is no longer mechanically possible. The rail abandoned flight in fewer than 100,000 generations, despite living within a storm track where wind velocities exceed 35 knots for more than 180 days per year. This occurred because the metabolic cost of maintaining flight muscles outweighed their utility in an environment with zero native mammalian predators. These adaptations perfectly suit a static environment, but they remove the mobility needed to survive a sudden biological breach. This vulnerability extends beyond the land and into the surrounding oceanographic boundaries. The archipelago sits at the confluence of the cold Antarctic circumpolar current and the warmer South Atlantic gyre. Surveys of the nearshore Macrocystis pyrifera kelp forests, conducted by Cazell and colleagues, show a highly stratified ecosystem. These forests are defined by a specific imbalance. They support an exceptionally high biomass, but do so with a remarkably low level of species richness. This chart tracks the boundary between the northern islands and Gough Island. Surface temperatures drop from 18.6 degrees Celsius to 14.9 degrees, while salinity shifts from 35.23 to 34.57 PSU. Deep-sea cameras were deployed to determine if this environmental stratification continued into the abyssal zones. These results from the Permanova test analyze fish community structure by depth. The community structure is split precisely between the 0 to 750 meter zone and depths exceeding 750 meters. High significance p-values confirm that a sudden biological discontinuity exists exactly at the 750 meter boundary. The surrounding ocean is a highly stratified system with low functional redundancy. Any external disruption to this trophic web risks a rapid collapse. When these biological and physical barriers are breached, the systemic risks compound. The perimeter of the island makes physical escape impossible for terrestrial species. The global population of Atlantisia rogersi, roughly 5,000 to 8,000 breeding pairs, exists entirely within a 14 square kilometer footprint. A breach of this type is currently playing out on the neighboring Gough Island. The introduction of the house mouse led to aberrant evolutionary divergence, creating oversized rodents that exhibit predatory behavior. These mice now hunt the chicks of the critically endangered Tristan albatross directly in their nests. Because absolute isolation prevented natural predators from evolving, the endemic population has no behavioral or spatial refuge to fall back to. This brings us back to the May 2026 Andes hantavirus cluster radiating from the cruise ship. We have a virulent pathogen in a naive system, with a reproduction baseline of 6.4. The physical barriers that isolate the island simultaneously prevent the delivery of medical and ecological assistance. Satellite monitoring has also identified a shift in the island's physical topography. Radar interferometry data tracks the structural integrity of the eastern cliffs. The map indicates severe structural deformation and accelerating microtectonic stress. Structural collapses on this scale threaten the coastal hydrology and the primary breeding access corridors for the island's marine species. The convergence of a novel pathogen, physical entrapment, and tectonic instability leaves this specific biosphere without a spatial refuge buffer.